Okay, so now we're a little bit familiar with Pythagorean theorem, and we want to make sure that we know how to use the formula. Again, our formula is a squared plus b squared equals the c squared. Remember, a and b are always going to be your legs. It doesn't matter which one is which because you're adding, and adding you can add in any order to get the same number. So I'm going to call my a this side and b this side, right? Doesn't matter which one goes where, but they have to be the two sides that make the right angle. The longest side, or the side across from the right angle, is always going to be your C, and that is your hypotenuse. So that always has to be there. A and B can be either way, but C always has to be the hypotenuse and will always be the longest side. So, knowing that, let's go ahead and put our Pythagorean theorem to use. So I'm going to look at this first one on the left, where I have a squared plus b squared equals c squared. Now, this one I'm trying to find what is c. Okay, so let's plug in what I know. I'm going to call 12a, and I'm going to call 5 my b. So I'm going to say, all right, a I know is 12 squared plus b, which is 5 squared, and that is going to equal c squared. Now, whenever I have a number with a square on it, I can go ahead and simplify that and take care of that. So 12 I know squared is 144, 5 squared I know is 25, and that's going to equal c squared. Well, now I have two numbers that I can add together. 144 and 25 is going to give me 169, and that equals c squared. Now, I'm not done yet because that is c squared, and I'm looking for c. So to get rid of that squared, I need to undo it, and I'm going to undo it with a square root. Square rooting it is the opposite of squaring it and takes that out. So if I do it to that side, I have to come over to this side. And the square root of 169 is 13. And so that is my missing side. And I know that's true because 13 is the longest side on here. It's bigger than 12, it's bigger than 5, and so I know that's my hypotenuse. Now, if we come over to the right, sometimes they look a little bit different. If you notice on this one, starting off again with my formula, a squared plus b squared equals c squared. Now this time, I have the c. I have my hypotenuse. They gave it to us. I'm going to call a, but what I'm missing is b on this one. So again, I'm going to substitute into my formula exactly what I have. I know a is 7 squared plus b squared equals 20 squared. So all I did is I took the numbers that I know and plugged them right into my formula, substituting the numbers in for the letters that I have. And notice you have to keep those squares. Okay, again, I can go ahead and take care of the squares that I know. 7 squared I know is 49 plus b squared, I don't know what it is, so it stays there. And 20 squared is 400. So now I can come up and do some subtraction. I want to solve this and treat it just like I would an equation. I want to keep b squared by itself. I want to isolate that so that I can solve and figure out what it's going to be. So, to solve this, just like I would with regular equations, I want to take 49 away from both sides. By doing that, it's going to make this equal 0 and leave me alone with b squared. Now, I need to do 400 minus 49, which I know is 351. And then the last step I have to have is to take the square root of that number. And if I take the square root of that number, it's not going to come out to be a perfect square. So what I'm going to do is I'm going to bust it out in the calculator, and I'm going to get that b is 18.7 when I take the square root of both of these guys. So that's how we're using the Pythagorean theorem.